Uh, we'll see if we can do this one quick, but no promises here. Well, actually, let me hop on the Discord. Oh, hey, Anders, congrats on the first. We're getting the actual reading group. Let's see if we can figure out this question quickly, but I might need to make you wait, Thunder. It's going to be too long. Suki said they would be here, but a little bit late. Inbox, I'm not sure, but actually, let me make sure the YouTube stream is up and running, so I don't forget. Okay, good. A tall smooth cylinder contains air atmospheric pressure of 1 times 10 to the 5th pascals. The density of air in the cylinder is 1.20 kilograms per cubic meter. Okay. I've seen if I can speed run this question from Thunder. The answer is supposed to be E, I think he said. And then we'll get into the group. But if we can't speed or run it, then I'm just going to come back to it later, and I'll DM you if I have to, Thunder. If you're not able to stick around. The piston is now placed in the top of the cylinder and allowed to fall slowly downwards, compressing the air until the piston rests in equilibrium. The mass of the piston is 50 kilograms, and the cross-sectional area is 0.02 square meters. Density of air in the cylinder and the piston rests in equilibrium. Ooh, so when does the weight of the piston exactly equal the force, the upward force from the pressure of the air? Yeah. So atmosphere, density of air in the cylinder. So we have to we have a force due to gravity going down. And then we have a force, I guess due to pressure P going up. That's probably not the best notation, but we need these things to be equal. And pressure is force per area. We're only given the pressure before the piston gets in there. We need to work out the density of the air in the cylinder. Oh god, I don't know this. I'm not going to know this quickly, Thunder, I think. So unless someone in chat puts an idea quick, I think I need to make you wait on this one. Hey, Stookie.
Hey, how it goes?
Pretty good. How about you?
It's been a funky 24 hours. There was I don't know if you know Jacob Geller. He's a YouTube guy.
I don't think so.
But yeah, he's I mean, very briefly, the like a Jewish games critic, and was doing a every year does a single stream on Twitch, raising money for some charity, and it just ended an hour ago. So I tried to see as much of that as I could.
Oh, neat. Sounds like a cool thing. I was just trying to speedrun this question from Thunder, but I don't think I'm going to understand it quickly enough. I'm not saying to do P1 V1 equals P2 V2, but I don't know how to get the density of the air to matter in that, so that's where I'm kind of like not sure. We need to do a bunch of Googling. I think we'll just get into the actual reading group.
Oh, I see.
Or I don't know if you happen to know how to do a question like this offhand, Suki, but I sure don't.
Well, I would have to read it at least.
Yeah. Okay. No. Never mind. That it sounded like you were about to like say something.
I
Um,
see.
the link for the Excalibur is in the text chat for the voice chat. But I'm just going to delete the question, and I'll figure it out another time.
Hi guys.
Hey, $10.
Hey, FM.
I thought I had an idea of how to do that pressure problem, but I was getting the air pressure going from starting from 101 kPa and going to 25 kPa. It doesn't make sense it would go down
Yeah.
if pressed. So I must have been making a mistake.
Huh. That's weird. After this critical, yeah. Thunder got the same.
Oh, did you? Yeah, I got 25 kPa, and I'm like, well, that can't make that unless the. Oh wait, is there any chance that the volume got bigger? No, it doesn't make sense. Oh, did you get 2,500? I got 25,000. I got 25,000 pascals.
Trying to think how. Yeah, I'm not sure. Like, I guess you use the density to figure out the volume or like how much air you actually have in the. Oh, okay. I guess I kind of see how you might do it, but yeah, I'm still not sure. Are you all able to find the link for the reading group or the Excel draw?
Yeah.
Yeah.
Okay. Oh yeah, $10. How's your day going?
Going pretty well. Going pretty well. I just did way too many Sudokus.
Nice.
So, it's I don't know if that's a bad thing. Probably.
I think it's a good thing. It's fun. Okay. So at least I just figured we'd kind of be going down the list, and the only ones for the problems that are remaining are 6, 7, 8, and 9. So I brought in 6. I haven't actually read it at all yet, though. So maximum field from a passing charge. In a colliding beam storage ring, an antiproton going east passes a proton going west, the distance of closest approach being 10 to the minus 10 meters. The kinetic energy of each particle in the lab frame is 93, I think it's giga electron volts, corresponding to gamma equals 100. Okay. In the rest frame of the proton, what is the maximum intensity of electric field of the proton due to the charge in the antiproton? For about how long approximately does the field exceed half its maximum intensity? There's a lot of words in there.
All right.
So Thunder's asking about annihilation, but I don't think they're going to actually touch here. We're given there's a very small separation. So what's actually... We have the antiproton going east. And the proton going west. I guess that vertical distance is 10 to the minus 10.
Yeah. Take that.
And so in the lab frame, where we're stationary and we see both of these particles moving, they have 93 GeV kinetic energy each. rest frame of the proton. What is the maximum intensity of the electric field? At the proton due to the charge on the antiproton.
Okay.
Okay, so
Charge is moving. I guess both are moving, so
in the lab, I guess, yeah, but we need to switch to the rest frame of the proton. So if we do a separate drawing down here, we'll have the proton at rest, and then the antiproton is moving even faster to the right.
Can we work out their velocities based on their kinetic energy?
Probably.
Yeah, but we also know we are given the velocity.
Oh, we have gamma, yeah.
Yeah. Or at least, yeah, in the lab frame. So somehow to remember how to do that translation.
I think in that appendix, they talk about energy in different frames.
Yeah.
Oh, okay. Velocity squared.
That's an annoying formula. Oh wait, no, is that E energy? It should be, rather than field.
Yeah, I think E was the energy.
So E prime is equal to gamma E minus beta gamma C, and then the x component of momentum. Just throwing a whole bunch of constants at us. And so I think E is the energy in the lab frame, and E prime is going to be the rest frame.
Makes sense.
I hope, at least. But actually, so if we want the momentum in this formula, we wouldn't need the mass, wouldn't we? Unless we can... work it out some other way.
Right.
It does have something to do with like the momentum is the rate of change of energy, kinetic energy. With respect, I guess it's just if you take the derivative with respect to velocity, though. Aren't they? I thought they were saying.
Oh, really? I guess, yeah.
Yeah, I was just doing the part roll in my head mentally, but they were saying something about they weren't necessarily talking about like forces. They were talking about the derivative of momentum, and I didn't quite understand why, but
I think the force, yeah, that's a force. The derivative of momentum is a force.
oh yeah, for time. Okay.
Yeah.
Yeah, that was Newton's second law. Some of the forces is the time rate of change of the momentum. I think that's how we set it up initially.
Okay.
Do we want the energy, like, would it be enough just to have the velocity of the antiproton in the proton's frame?
You have to have the maybe?
And I'm just asking because then we wouldn't need the mass. Like, but
Yeah, we should probably maybe the mass is the most important thing to focus on right now. We should, yeah, because this might even be the right like approach. So if gamma's 100, can we work out what v over c is, I guess, or beta? It's gamma is equal to 1 over root 1 minus beta squared, I think. So we could work out what beta is.
oh no, okay. I thought that was gonna be very silly, but it's not quite as silly as I thought.
Wouldn't be the first time I've done something that's very silly. And then Wolfram. Squared. Okay, but that is a number. Can't say it's my favorite number. 3 root 1111 over 100.
For 100. Right.
Anuj over on YouTube. This is a reading group I'm doing on Saturdays for electricity and magnetism. Basically work out problems as a group here. I kind of want to see this as a decimal. I feel like that'd be a little more helpful.
0.99995, basically.
Nearly the speed of what the hell?
Oh, sure.
It's 4 nines, yeah, and then a 5. Okay. That's
A little bigger than I thought it was, but
yeah. Does Excalibur ever get laggy? Yeah, the more things you have on it, it'll eventually start to slow down. You just have to make a new one when that happens, and it's okay. I guess gamma equals 100 is a pretty big number, so maybe that's not unreasonable.
right. We were thinking about gamma equals 2, I think, in a couple cases before, so. Just gonna...
Maximum density of the electric field. Hey, Nand. I feel like I think the goal is to work out what the velocity of the antiproton is in the proton's rest frame. And I think that on its own is enough to know what the maximum intensity of the electric field should be, because we know how that field looks then.
Yeah, that makes sense to me.
And I'm curious if we get the velocity, like we have two ways to get the velocity, it seems, like one from the kinetic energy and one from gamma. And I assume they should match, but I don't know why they, like, maybe they wouldn't. I don't know if there's a difference.
I mean, I would expect them to.
Okay. How do we work with a giga electron volt? I'm not good with the units.
So an electron volt.
Trying to remember where they introduced unit conversions. Wait, there's stat volts, but that's different from an electron volt. Ugh. And of course, this appendix doesn't go into electron volts. Thunder has part of a conversion.
Yeah, 1.6 times 10 to the minus 19 joules, I think, is an
Oh,
electron
joules.
volt.
Okay. So then we have 93. Wolfram Alpha can do this for us. Okay, 1.49 times 10 to the minus 8. That seems like a small amount of joules for how many... I guess electron volts are small.
Yeah, that's a whole joule in that electron. Oh, no, it's not. I see.
10 to the minus 8 joules. It does seem a little small, but I don't know. I don't think Wolfram Alpha is going to lie. I hope not. The conversion factor is pretty dang small, so... Like, gig is like times 10 to the 9?
Yeah.
Or something? So...
Sounds right.
That seems reasonable.
Do any of us know for sure if an antiproton and a proton have the same mass?
Yeah.
They have to, I think.
They do? Okay.
So if we took this number 1.49 times 10 to the minus 8, we multiply by 2 and we divide out the mass of a proton. Wolfram Alpha is going to give me something that's not helpful? Or... Ugh. Is a joule per kilogram velocity?
Newton times a meter. I
don't
think it
think
is
so.
actually.
Really?
It's a Newton times a meter, and a Newton is a kilogram. Oh no, it's a square of a velocity. It's a velocity squared.
Oh yeah, so we have to square root it. Okay. I just want to see if this agrees, like... Okay, so this is saying 4.22 times 10 to the 6 meters per second.
Was
That
that
seems-
faster than the speed of light?
3 times 10 to the something. So that might be an issue if I didn't do this right.
Kilometers per second. So
Oh, it is.
yeah, that
Okay. You're right. So 10 to the 9 for meters per second. So then what's 0.995 times c?
Not that.
Okay.
not 14 times c.
That is more than the speed of light. Okay.
yeah.
Well, that's not good.
But there's a different energy equation, right?
Um.
Oh, one with relativity involved.
Yeah.
Oh. I thought in the lab rest frame we wouldn't have to worry about that.
Well, it's moving.
I was hoping. Okay.
Yeah. The momentum.
Get rid of that now. If you believe hard enough, anything is possible, so it can go faster than the speed of light. Yeah, I mean, what did Einstein know?
Question.
Hmm. So intensity, field. Okay, I mean, if we already know beta from like working backwards from gamma, though, can we just do that velocity? I assume it's the velocity addition formula to get the velocity of the antiproton in the other frame.
Yeah.
I think that's the formula Stuki got earlier, is it?
Oh, it does look like that.
The UX prime.
Yeah.
Velocity in F, velocity of F prime in F. Is Minesweeper gone? It should still be there. And on this is the electricity magnetism. Actually, what does that corresponding to gamma equals 100 mean? Now I think about it. Like, that means like which velocity does that correspond to? Of each of these
Both.
particles? Okay.
Yeah.
Yeah,
So
if they have the same mass, then that would be from the lab frame, wouldn't it? From our lab frame point of
Right.
view.
seem reasonable?
This is u sub x prime?
Yeah, except wrote some things down wrong, but should be 9. I'm trying to multiply that beta by 2. That's what I'm trying to do here.
Oh, okay. I think I see where this is coming from now. I think this looks good to me. It's apparently just the speed of light.
It's real close. I'm getting
Oh,
1, 2, 3, 4, 5, 6, 7, 8 nines.
8 nines, yeah.
Yeah.
8 nines and then an 8 7. Yeah.
Some fast protons here. And so this u sub x is going to end up being the velocity of the antiproton in the proton's rest frame. Which
Right.
seems like reasonable that we got this.
Yeah, I'll buy it.
Given the lab frame and the velocity are so high. That's a clever way of writing it.
Okay. And then do some magic with the electric field equation.
Yeah, I'm just looking at that. So the parallel component never changes. The perpendicular component
Right.
needs a gamma factor. So this is the electric field from the antiproton. So if we take the proton as our origin, I guess, x and y, oh, in the proton's rest frame, let me just do an arrow. So the parallel to the velocity component is good old Coulomb's law, which is an antiproton is minus e charge 4 pi epsilon naught, and the vertical distance is always 10 to the minus 10.
Right.
I guess that's y hat, isn't it? Nope, that's x hat. And then the perpendicular electric field in the source, well, that's in the source frame. This is not the source frame though. How do we deal with that? Or do we still, I want to divide out a gamma from the lab frame's Coulomb's law. Can we still do that?
We could. We need the frames Coulomb's law, but that's not so bad.
I'm just not sure if I'm misusing the formula by doing this. Then we have, wait, x hat. It's the parallel component. I guess maybe I should be defining y to go down. Because it's gonna be, well, they're attracting each other. It should point
True, yeah.
up. Okay. This is weirdly x meters for the y hat direction. But I think I need to get rid of the minus sign, or I need to have another minus sign in here. It should be positive if I have it like this.
Right.
Actually, so wait, how am I using the velocity that we just worked out though? Do we need the gamma is different? Is that it? It's not the same gamma?
Where are you referencing this?
For the field?
Yeah.
I was just basing it completely off of in the chapter summary, they just say the field in the lab frame for parallel to velocity is equal to the field, or the parallel to the velocity, the electric field is the same, perpendicular. There's a factor of gamma. I'm just looking at the chapter summary.
Mm-hmm.
But I'm afraid that I'm misusing this. Maybe I should actually be using the next formula that I'm... that was probably a simpler one.
Point charge moving with constant velocity. Oh yeah, that's good.
Okay. I like that a lot more. Oh wait,
Yeah,
so of a point charge moving with constant velocity, okay, yeah. And antiproton is our point charge with constant velocity. And that's just the magnitude, but we only care about the magnitude though, I think. Yeah.
Right.
Or pi epsilon naught. we're going to have a distance x squared plus 10 to the minus 10 squared. That's not square rooted.
Right, it's not.
Times 1 minus beta squared over 1 minus beta squared sine squared beta to the 3 over 2. And what is theta?
It's like this.
It's that angle? Okay.
It's either that one or the other one.
Yeah, so I'm trying to figure out which one of those.
Yeah.
The heck? Where did they get this? Oh. No, that's not it.
Is the angle between the radius vector and the velocity of the charge. So the velocity of the charge is indeed positive the x direction, and the radius vector, that is how the distance, the line connecting the two. So I think that's right.
It is? Okay.
Yeah.
And then, so we could say that sine theta is equal to, the opposite is always 10 to the minus 10 over root x squared plus 10 to the minus 10 squared. Is this beta the same? Oh, I guess we need to get beta again from this u x prime.
Right.
And so that's just the thing that you wrote, but without c.
Right.
Okay. Okay.
1.25.
Why did I make that a 12?
1.12.
Thank you.
Again, I'm just here to, keep an eye on you guys.
I definitely need it. I won't speak for Stookie, but squared over 1 minus. Ugh. I'm gonna let Wolfram Alpha do the actual. We have to take a derivative of this thing, I think. So I'm definitely not doing that by hand.
Oh no.
No?
We're not. I'm not taking a derivative of that. I'm saying that thing is going to be maximum when theta is either
Oh.
0 or 90, and it's probably 90.
You make a strong point. So actually, we don't need to give the actual value of sine theta then. Well, wait. Oh, but doesn't the
For the second half, we might want, but
I guess beta is a constant, so we don't need to worry about something weird happening with where it is in the field changing. I guess it should just be strongest when it's closest then. which is 0, right?
90.
90? Doesn't sine... Oh, yes, okay, because of how theta is defined. Okay. So it's just, we're just saying that sine is 1. That'll be a lot easier.
Yeah.
Sine theta equal 1 when field... I mean, we do have to... I guess part 2 of the question might need something like that, though, but...
Right.
I was just worrying about one step at a time. So I'm just going to plug in a 1 for sine theta. And that means x is 0.
X is 0, yeah.
And that's a number. Minus charge of, I guess, antiproton, but it's just charge of electron. Minus charge of proton. That'll 4 times pi times relativity of free space. Hey, hardlocked. Yep. 10 to the minus 20 meters squared. Does this just the the 1 minus beta squared's... No, we have a 3/2. Never mind, they don't cancel.
Yeah.
Unfortunately.
Sad.
.25 times 10 to the minus 9 squared over the same thing but to the 3/2. I think beta is unitless. Yeah. Hopefully Wolfram Alpha knows what to do with this. Why can't you be normal Wolfram Alpha? I just want you to do the units for me. Kilogram meters per second cubed ampere. That's not quite right. I really wish this thing worked how I want it to work.
Newtons per coulomb. Yeah, I think that is newtons per coulomb.
Really?
Yeah, because an ampere is a coulomb per
Oh,
second.
you're right, Fembox. Okay. Yeah.
Okay. Yeah, that's a Newton.
I thought the, yeah, I forgot it was newtons per coulomb. I thought the charge needs to be in the numerator. Or minus 1.44. Times 10 to the 11. Oh, wait. Positive 11. That's pretty strong force. I guess they're going really fast. Well, that shouldn't...
They're really close to each other. Maybe is
true. Yeah. Okay.
Because that second factor is like... Think about that for a second.
Basically
it's
1. Yeah.
1 minus beta. 1 minus beta squared is basically 0. Right?
Wolfram says it's basically 1.
Cool. What the fuck?
Okay, they made us do a lot of work. We could have just like said it. They're going fast enough. We just make it 1. Okay, I guess it's an answer to part 1. And just like I see in the YouTube chat, Nutmeg asks where you can get hard E&M examples to practice on. I'd say this textbook that we're working out of is really hard. Efficiency magnetism by Priscilla Morin. And Pretty Lotta asks if we can solve electric solenoid questions. Ooh, I don't think we've gotten there. Or at least we're only just barely getting there.
Yeah, probably not.
Okay. So part 2, for how long approximately does the field exceed half its maximum intensity? I guess we don't need to do a derivative here. Because...
Right.
Yeah. I should get rid of the vector.
True.
E max over 2 is minus 0.777? No.
72.
Oh, yeah, 72.
70, okay. And times 11 newtons per coulomb. And we can just set that equal to E and solve for X, or Wolfram Alpha can more accurately.
Sure. Yeah, since we have theta in terms of X, why not?
Minus 0.72 times 10 to the 11 newtons per coulomb equals that.
1 minus beta.
Oh, Wolfram. Okay, let's get rid of the units. Oh wait, but I need the maybe I need
Did
more.
Did you bring the sine theta term back into it, Don?
I did.
Okay.
All right, I never deleted it. I just like copied it. Aha. Okay, so these x values happen at plus and minus nearly at 10 to the minus 11. X is about plus or minus 9.99. I guess it's not quite, but 99998. I'm calling it 10 to the minus 11. And then we just need to figure out what time that happens at.
Right.
All right, so how long is it within this range for? And we know... Well, do we have to worry about time dilation? Or which frame are we asking about?
Yeah, I think we will have to, at the end, undilate the time.
Okay.
Or you don't have to do that first, right?
Oh, I don't know what frame they're asking us to get this time in.
Probably the same frame, I guess.
Yeah, that seems reasonable to assume.
Oh yeah. No, I agree. I thought we'd go back to the lab frame, but I'm convinced.
And so our use of x prime still works here. So we take 1 minus 1.25 times 10 to the minus 9. C and set it equal to, I guess the distance is 2 times 9.998 times 10 to the minus 11 meters over time. And that will give us the answer that we want. 1 minus 1.25 times 10 to the minus 9. Wait, where does that c go? This c should be outside the parentheses. Oops.
Good catch.
Hey, Dinosaur, you're taking classical field theory this year? Nice. It's been a minute. I hope you've been well. What am I doing? Flipping each side. Okay, see, I want to do 2 times my thing divided by 8 times 10 to the minus 11. Ugh. We'll put meters in. Oh. All right. 6.67 times 10 to the minus 19 seconds.
Whoa.
Short time. But
Really?
I assume it's not unreasonable. Should we check the answer, or anyone want to keep thinking?
I don't know. Does that feel too
Wait.
small? It's very small.
Yeah, that feels too small.
It's going nearly the speed of light.
Right. If it were actually going the speed of light, then it would take what, like a third of a second or a 30th of a second? Or sorry, in meters, maybe. Because it's what? What was that conversion we kept using at the last problem? It was like 1 millimeter per nanosecond or something like this. 1 centimeter per nanosecond.
Oh.
I forgot.
So,
I forgot it. Yeah.
but then the number of meters, like the number of centimeters, is also okay. Never mind.
You okay with it now?
Yeah.
All right. Let's cross our fingers. This is
Yeah, let's
number
cross our fingers. That's what I'm thinking.
6. How was I cheating, Thunder? I'm also not above cheating, but I don't think I was. Okay. You know, well, I can't resist. What's the final answer? 2.88 times 10 to the 15 volts per meter? That doesn't sound like what we got.
We got half of that, didn't we? We got
in the wrong
1.44.
order. We're way off on the order of magnitude. What about the time? I guess that messes up our calculation for the time.
Sure.
Oh yeah, the time is way longer. 3.83 times 10 to the minus 5. Oh wait, no, that's alpha. What is alpha? It's 2.6 times 10 to the minus 23 seconds is the answer they got, which is not okay. It's shorter.
Oh, that's less time. Wow.
Not unreasonable.
Okay, so what went wrong?
So what's the order of magnitude that we're hoping for here?
The book claims. Where am I? Okay, the book claims 10 to the minus 23.
Okay.
Two point 88 times 10 to the 15 volts per meter.
So we're off by half, and then also like 4 orders of magnitude.
Yeah, wait. Okay, if we really think this second factor is like essentially 1, then this first factor here, oh no, because it's got this epsilon, which is doing annoying things. Okay.
So they're also saying that beta lab is about 1. But well, what did? Okay, yeah, so we got that 0.9995. But that means their gamma.
Did we need a more complicated formula? Because it seemed like we used the formula from section 5 where there was like one thing moving, like one particle moving, but I guess we changed to the frame where we were considering the proton fixed, right? So
Right.
then okay.
Again, 5.15. I'm gonna. Okay, 5.15 is the same one that we were using. Gamma Q. Oh, okay, so we're off by 2 and 4 orders of magnitude because I think because of what you're saying, Fembox, like we needed to introduce a gamma factor because they were both moving, like a slightly different gamma factor. We otherwise have the formula, I think, spot on. But if you take our answer and multiply it with their gamma, I think we get the right thing. I'm still not sure
In the
why.
chapters, yeah.
Oh, I'm still not sure why we need
In the
that gamma.
chapter summary, yeah.
Go on.
Sorry, Don.
No, sorry. You talk.
Okay, I just look at in the chapter summary in equation 532, where they're talking about the ratio between the forces. And I don't know if that's where that extra gamma came in.
Hmm. I feel like we
I
shouldn't
don't
have
know.
to
It
involve
feels like
forces.
because both things were moving. It feels like because both things were moving that maybe there was an extra complication that we might have skipped over.
Okay, so they refer to equation 5.15, which does not have a gamma anywhere in it. But in their solution, they throw a gamma in without, and they don't seem to explain it. And I assume that's because of what you're
5.15,
saying,
that's the one we did
Fembox.
use.
Yeah, but they use. Oh wait, no, they're saying the gamma is equal to 1 over 1 root 1 minus beta squared. Maximum value of the field is achieved when theta equals 90. Wait, so what is... If theta equals 90... Oh, it does just become a normal gamma. But our gamma was
It
different.
does. Yeah, when theta is 90 degrees, the second fraction in that formula just turns into another gamma, doesn't it? Because it's 1
Yeah.
minus beta squared on top, and it's
See.
1 minus beta, the square root of 1 minus beta squared on the bottom. Oh, or is that the reciprocal of gamma?
It's gamma. Because gamma has the 1 over built into it. So we said that entire thing on that second factor was 1, and that was the improper part.
Whoa.
For reasons that I don't understand yet.
Okay.
It should be 2 times 10 to the 4th.
Sure.
So they're saying beta equals 2 beta lab over 1 plus beta lab squared. And then the gamma factor associated with this speed. I don't know where this is coming from. They're saying as we can verify, so.
That sounds like the calculation Stuckey did for the velocity. Wasn't that 2 beta over 1 plus beta squared?
Oh, it is, yeah. And so they bring it to, how do we not get the same thing? Beta lab is about 1. Oh no. Wait, I think I messed up. Stuckey, you found that the u sub x prime is that it's nearly c. And then when I made it beta, I removed the c thinking that we should divide the c out.
Right.
But that seems to not be the proper. I think the c needed to stay there?
No.
Or...
Yeah, I mean, when I plug in that expression at the end, you know, I do get 2 times 10 to the 4th. Yeah.
Really?
Yeah. Actually, a little more than that, which is kind of concerning, but okay, I'll have to think about that.
I need to make a sigh and counter. You're right, Thunder. I do those a lot. Sorry, I didn't hear that last part. Beta lab's about 1. I kind of hate that they're kind of doing 1 minus, like they're doing 2 divided by 1 minus 1, but they're not actually doing it, I guess. I feel like I feel like we got the right number, but it should have worked out the same, even if we made it a little more complicated. Like they simplified it earlier, but ours should have simplified the same.
Yeah.
Did ISOL mess up the input into Wolfram? I would believe it.
$12. So we've got
Yeah, 19,611. Oh, that's about what we're out by, isn't it? 20,000? Yeah, you know, when I did this, I plugged the wrong thing into my calculator for the beta. No, I agree with what
Oh.
you said, Stuki. I agree with what you said. That second fraction doesn't turn into 1, it turns into 20,000.
I definitely plugged something in
Right?
then.
Yeah, I think so.
This one here that we were looking at, I just turned this into 1. I mean, I think, and that was my mistake, but I don't think it is 1 at all. It's like 20,000. And if we multiply this answer by 20,000, I think we're on the money. Was it a Wolfram thing? Maybe, I don't know.
It looks like I input it correctly to me, but that doesn't necessarily mean a lot much. No, I'm still getting 1.
Yeah, because it should be 1 minus 1 minus 1.25.
I think you're making the
Oh.
same mistake I made, Don. I didn't put the 1 minus on it. Yeah, I had it stored without the 1 minus.
Oh, no. Stupid. Okay. Well,
20,000. Yeah, there it is. Yeah, there it is. No, that's not a big deal. I mean, see, you know, the method was correct.
that's true. And so we get the exact right answer when I fix my Wolfram Alpha input.
Nice.
Okay.
Yeah.
It's a terrible looking too. Okay. I'm just gonna put a slash through all the rest of work and not go through the pain of updating it. Okay. Okay, so other than that little Wolfram Alpha entry error, we did the problem right. Sounds like.
Okay.
I guess we didn't get a new value for the time. Wrong answer. It should be easy enough to update the value for the time, though. Meters squared plus minus 2.88 times 10 to the 15 newtons per coulomb equals that. I'm getting imaginary time. That's not good. I don't want to go that deep into relativity. What sign mistake did I make? Time is imaginary, made it up. Apparently imaginary time is a real thing, as far as I know. Or it is theoretically real. I don't know what it means, though.
Squared.
Uh,
There's no b squared. Oh. Can you just change one of those? One like that sign out front?
oh, just arbitrarily remove one? We can see if that fixes it. How is it still imaginary? I guess they're canceling in the first step anyway. Let's simplify that second factor because we know it cancels. I don't know if that's what that shouldn't be the thing that's making the error. Still imaginary. It's not a big deal. Like we should be able to get the right answer from the side. I don't know what's going
Did you
wrong right
divide
now.
the
But...
maximum by 2?
Oh, I sure didn't.
1.44.
Good call. Between statistical physics and quantum path information by considering imaginary time in a factor. Oh, there we go. That's wait, no, that's not the right.
A real distance.
That's a distance, yeah. And then we need to do.
It's the same real distance, though, right? Or are there more 9s?
It does look about the same.
99997. Oh, it's the exact same number.
Okay. I don't see a sine theta here. There should be an x in the second factor.
Oh, because now we're not taking it. Well,
Right.
Okay. Then we can't do the nice cancellation. Okay, so we need this thing in the numerator. Again, that becomes 3/2. And we multiply that by sine theta, which sine theta squared, which is x squared over square root x squared plus 10 to the minus 10 meters. Well, all those units should cancel, so I'm not going to include them. Where are my parentheses starting and stopping here? This one needs a friend right there. Let's see how Wolfram interprets that, and then in critical, sure. Oh wait, but it's sine squared, so I take the square root back out. Ugh, okay.
And then 10 to the minus 10 instead of x in the numerator?
It is up. Ooh, true. That's not the right parentheses. Hello. So chromosomes imaginary temperature. What? That's crazy. Okay, this input seems complicated but reasonable now. And what answer? Oh, Wolfram Alpha doesn't feel like. Ugh. Okay, well, I think this is the right setup. But I'm willing to just
You got
say it should give us the right answer and not check it. Wait, oh, yeah, okay, never mind. Okay, yeah, let's just move on, I think. Unless someone really wants to verify the time part.
Yeah.
All right, just took an hour and 25 minutes for that. Gonna be the goal for math students to look at physics, but I'm daring. Yeah, physics is fun. Even though that is sacrilegious to say. Okay, so this is gonna be the last meeting on chapter 5, and we don't have time for, at best one more. Let me look at the last 3 questions that have the answer keys provided. Uh, number 7 looks like there's a lot going on. Hey, Joseph. Number 8, consider second scenario in the example. Show the total force. Maybe. No, 9 is twice the velocity. Suppose the velocity of the test charge in figure 5.22 is chosen so that in its frame the electrons move backwards with speed v naught. Show the beta associated. The net charge density. I think 9 looks the most interesting to me.
9 part A looks
Yeah.
very familiar, doesn't it?
Oh, yeah.
It sure does. Frame.
Okay, we have 3 screenshots that I took for 9 because they refer to a few things here.
Right.
One of these screenshots is going to be a chunky one. Oh yeah, they're referring to that giant, like an entire
Right.
page for one figure. And this beast of a formula. I was wondering where
Oh, boy.
both of your fields of studying experience within that field in terms of the subfield you both studied. For physics, I only-
Also, there's 3 of us. Hello.
Yeah. So I guess I'll just say, yeah, on the call is me, Stoogie, who just talked, and Fenbox Fam.
We're all math guys, as far as I know.
Yeah.
Mhm.
I don't think any of us have taken physics class beyond like what we are required of like a math major. So for me, I did 1 semester of mechanics, 1 semester of E&M, and that was years ago.
Pretty much the same.
So far, math guys with an A, but after you do a couple of these problems, you feel like you got to turn to something.
Yeah. Gotta take the edge off.
Oh, goodness.
Okay.
There's the lab frame.
So number 9 asks, suppose the velocity of the test charge in figure 5.22 is chosen so that in its frame the electrons move backwards with speed v naught.
Okay, so we want them to go...
So we're just reversing that arrow?
That arrow.
Or yeah. I mean, okay. Show the beta associated with the test charge velocity in the lab frame must be beta equals 2 beta naught over 1 plus beta naught squared. Why does that direction? Oh, because I was about to say that it should be symmetric, but the test charge also has a velocity to the right. So now they're opposing each other rather than agreeing with each other. Oh, wait, 5.22. Wait, there's different stages. No. Yes?
Yeah, so the thing that's changing is the test frame charge V.
In its frame, the electrons move backwards. The velocity of the test charge in figure 5.22.
Nice. I see. So
Electrons move backwards with speed v naught. Oh, so is it? We're saying in the test charge frames. The velocity of the test charge in figure 5.22.
right. So we want the velocity of the test charge. Oh, I guess, sorry, I wrote the wrong thing. But we want it to be going faster so that relative to how fast it's moving, these electrons which were moving that way before now start moving in the other direction. I mean, just classically, right? Like if you start going fast enough, then eventually it looks like the trees outside are going backwards. The train next to you is going backwards.
Okay. Sure. Did they say when they were working this out to figure out that V was smaller than V naught? Or maybe that when they worked it out generally, made to show for it in a specific case. Either way, I show that the beta associated test charges velocity. Oh, I could see when we have the square root and squared business, so we might end up going into cases when we actually start to do some calculations. We need to know which one to choose.
Okay.
That's my assumption, at least. Beta associated with the test charges velocity in the lab frame must be 2 beta naught over 1 plus beta naught squared.
Okay.
So this should be the same work that you did up there in the last problem, though, Stuki, right? Like that same formula?
Yeah, well, I'm trying to see
Or
why
something
that
like it.
happens, right? Oh, but
Lambda is the linear charge density of the electrons and protons in that wire. And gamma is the, it's called the Lorentz factor or something for special relativity.
Yeah, Lorentz factor.
how does... How do we make sense of this? I guess can use the addition formula. Ux minus v over 1 minus. And then which do we know? We know, if I'm thinking about the test charge frame as the primed frame, then I know this. And yeah.
But isn't that shouldn't that be 0 in the test charges frame?
So I'm thinking about the U object as being the electrons that are moving.
Oh, yeah, okay. That makes more sense.
But I think actually they derive it the other way, so we don't have to actually invert this function. Well, they do both.
I think I got it here.
Okay.
I think I got it here using that formula that you're using, Stuki.
Okay.
Yeah, so if we plug in ux equals v naught, and the v is minus v naught. Now, I don't know how to justify what I'm plugging in,
Okay.
but if I let's see. Let me write something. Yeah, ux is v naught. Yep, and the v is minus v naught. Yeah, give that a shot.
It will
Okay.
give the correct result.
Let me try
Uh,
and okay, let me write something here. So we get v naught minus
oh,
v naught
hey, Phobos.
over 1 minus. Uh-oh, error.
Yeah.
Oh, come on. V naught minus v naught over c squared equals 2v naught over 1 plus v naught on c squared, v naught squared over c squared, right? Now using beta naught is v naught over c.
Yeah.
This is 2. Come on. I'm not very good with Excalibur here. 2v naught. So 2v naught is 2 beta naught c. 2 beta naught over 1 plus beta naught squared c, right?
Oh, okay. So where the extra C was going to come from.
Yeah. So the thing in parentheses is there's our new beta, I guess.
Oh, right, because this is U, and then we could just get the beta by dividing out the C again.
So, you know, if what I did is valid, then I don't know. If it's valid, it's valid. If it's not, then
It gets the results. So V is the velocity of the test charge frame as the lab frame sees it, which is basically the velocity of the test charge Q. And that is V, or ooh, we're saying it's V naught.
Or sorry.
Bayesian estimators, I don't have experience.
Oh. That's annoying. But yeah, it makes sense to me that there's some sort of problem here. Let's do the test charge. Chosen so the units frame. Oh, so we're supposed to be solving for V. We're supposed to be solving for V.
Oh.
Yeah, that's what's going on here. So the problem says, I wrote some other stuff down here. I don't think that's actually what's going on. The problem says that ux prime is equal to v naught. But the setup just of the whole thing says that ux is equal to v naught, and these should probably be going in opposite directions. Ux is equal to v is equal to minus v naught. And then v is the thing we're solving for, actually. But it's, I guess maybe it doesn't surprise me that much. No, never mind. It surprises me a little bit that everything works out.
Huh.
Although, no, not that much, because if you look at this, the other formula, ux prime and v are symmetric. We can trade one out for the other. Physically, I'm going to put that on pause for a second. But, so, yeah, here you solved for ux in terms of u prime x, but we should have solved for v in terms of u prime x, or excuse me, in terms of ux, so like same.
It seems weird to me that it's the same v naught on each side of the equation. That's what I'm trying to figure out.
Right. The point is the v naught, the black v naught, is like imposed by the setup, and then we can choose v, the velocity of the test charge, to be whatever we want, and so we're choosing it so that the same v naught shows up on the left hand side.
Oh, and that's why it's in quotes twice the velocity. Because if relativity didn't exist, we would just do double of v naught for
Right.
v.
Yeah. There
Okay.
you go. There it is.
Okay. And then so we take this equation and we solve it for v, and it won't be quadratic. Okay, that's what I thought. That's what I was afraid of, but just be linear.
Oh, nice. Okay. Yeah.
I guess if we go over to the far right. Oops. So we have minus v naught equals v naught minus v over 1 minus v naught v over c squared. Okay. Multiply each side by the denominator. It's v naught v minus v naught plus v naught squared v over c squared. Minus v naught is equal to, let me do this in multiple steps. V naught squared v over c squared minus v naught equals v naught minus v naught squared over c squared. So then v is equal to v naught over v naught squared c squared minus v naught. We could not wait. I'm doing too many things in my head again. No, okay, that is it a good thing or a bad thing if we cancel the v naught? That's not getting us the right answer.
About where our c's are.
Yeah, should have a C factor on the outside ideally. I think.
Oh, wait. And your second line of V naught minus V turned into a V naught times V. I think.
Sure
Oh
did.
my gosh. That makes the problem a lot easier too, doesn't it? Yeah, it does. Well, okay. Will I do a maths subject reading group? But potentially, yeah. This reading group has maybe 2 or 3 months more left in it. And then the world was our oyster after that. It kind of
Well, the world is already our oyster.
That's true, yeah. It's on what the other like parts of the math community are doing at the time. This is, aren't we? I did another mistake, didn't I? Because I'm getting V equals 0. The V naughts are cancel. Oh wait, no, they're not canceling. Minus V naught squared V over C squared. Is it? Oh yeah, because we distributed a V naught. Okay.
Looks good.
Let's just get rid of the negatives.
I was about to say you're liking your negatives there.
Yeah. C squared. This looks a bit more. We should still have the C on the outside though, shouldn't we? That's nearly right.
V naught.
Oh, you could put an extra C in it. Yeah, sure. Multiply and divide by C.
Ooh, but I don't want to mess this thing up. That's already our beta squared.
Yeah, but you'll get a beta on the top as well then. Isn't that right? Yeah, you could put a C next to it.
Oh, okay. So we can do times C over C, and then this 1 over C goes with the velocity to become beta.
Yeah.
Okay.
Yeah.
2 beta over 1 plus beta squared equals V. Oh, is this beta naught? I guess, yeah, it's beta naught.
Yeah.
So then beta equals 2 beta naught over 1 plus beta naught squared. Okay. Just a little bit of pain. I think we did it.
Yeah.
And then part B, using length contraction, find the net charge density in the test charge frame and check that it agrees with equation 5.24. So we're not actually using equation 5.24. We're just using that to verify our answer at the end.
Right.
So the net charge density in the test charge frame. So we need a we need to multiply lambda naught by gamma. Well, divide it by gamma. Well, we need to figure out gamma, which gamma, I guess.
Right. Which means that when we start moving the frame, we decrease the distance between ions, and so we increase the positive charge density.
Yeah, we do expect to. We should still get the same result as equation 5.24, and that's we expect to increase the density.
Mm-hmm.
This might be wishful thinking, but could it be something as simple as lambda prime equals 1 over gamma times lambda naught, where gamma is oh wait, no, sorry, just gamma times
Just
that naught.
gamma.
And then gamma is 1 over root 1 minus beta squared that we just got. Well, we need a regular beta in there, don't we? Unless it pops out later on somehow. Oh, wait, no, beta... Oh, shoot, I'm doing it wrong. Beta... Yeah, that's okay. Wait, no, that's okay. Beta not squared. Well, it might not be right, but... I'm plugging it in right. Squared. And I guess we have to supply this and hope that we get things popping out. Do you see it's Tuki?
No, but I sort of understand what being gotten at here. Because no, never mind, not the case.
Oh, or we have to do a setup that's more complicated, like they have in equation 5.24.
Right. So we still have positive and negative charges that are moving at different speeds.
Like, okay, because when we're in the test charge frame, the ions are going to be moving to the... Both the ions and the electrons are moving to the left, but not at the same speed.
Right.
The ions, I guess, are moving faster. Okay. Not that that part matters.
So then, oh, but gosh, yeah. I guess there can only be the same amount of length contraction. You don't contract differently between the ions and the electrons.
I think they are contracted different. They have different velocities.
But the contraction should happen like at the level of the frame, right? We move from the lab frame to the test charge frame. So that contraction, it's the same frame. The x has to be scale on the x-axis still should be the scale on the x-axis.
Okay.
How do we expect that? Guess something is happening, right? The same thing could be said in the original setup, and yet the contraction is different.
I'm wondering why we can't just use our value for beta in the equation they gave in 5.24 and show that both sides match. I I honestly don't know.
Right.
Because I feel like equation 5.24 also uses length contraction, so what's the difference?
Yeah. See what's going on near the figure.
Mm. Hey, Anchor, it's going well. How about you?
To the speed of the electrons in the test charge frame. So I guess the difference is that we know the speed of the electrons in the test charge frame. Like, that's not something we had to calculate. I don't know if that's a difference, but it might mean that we get and simplify the formula here.
Hmm.
Speed of the electron.
So yeah, in equation 5.24, they're converting the negative charge density. I feel like the term for the positive charges should be the same.
I feel
If
good about
anything's
that.
changing, okay. If anything's changing, it should be that second term in 5.24, which is what you were saying
Right.
too. And so they convert it into the density for the electron's rest frame first, which
Oh, that's interesting.
gamma lambda naught. So the gamma naught that we have here is minus, well, ugh. I guess it's still the same gamma naught. Because it still has V not in the lab frame.
Agreed.
And then it gets multiplied. So this is now, oops, lambda in electron rest frame. And now that we have like the, I don't know, like quote unquote fundamental density, we can convert it to the test charges frame. Which I'm still not sure how it's going to be different from what they already have written. But I'm trying to follow the same like process of how they set up 5.24 for a specific V that we chose. This is electricity and magnetism, and the problem we're working on right now involves some special relativity as well.
I guess my question is, why bother with the electrons rest frame? Here. Oh, they have to do it because they don't know, or because they know V not prime? Is that what the deal is? No, they don't know V not prime. But we know V naught prime. That's the advantage that we have. We know that V naught prime is negative V naught.
Okay, so we can go directly from the lab frame to the test charge frame when it comes to the electrons.
Right. And that should also be gamma? What? Just in the other direction? Gamma naught, maybe, is the deal.
Oh, wait, where?
Yeah, hold on. No, I don't believe that. I'm just trying to do that, to convert it directly from the lab frame to the test charge frame. But I guess that is just gamma, right? That's just how this all works.
Yeah, I'm losing track of how we're using these gammas and betas. I guess.
velocity.
Okay, Thunder. I'll DM you. Thanks for hanging out. Hmm. I'm not sure. I feel like I'm starting to piece it together, but I also feel like I'm just kind of getting stuck.
Yeah.
It's like I'm looking like in the figure they say like beta naught prime is equal to v naught prime over c, and like I think what you said, like we already know what that v naught prime is, but I'm still struggling with like what direction to take with this. And doing this over past 2 hour mark. As long as you all don't mind, maybe I can look at the answer. We can verify we did right for part A, and then I can look at the first sentence for the answer for part B or something.
I'm up for that.
Okay.
Yeah, I'm no help for this. I didn't quite get this far in the chapter.
That's fair. This charge sees the electrons moving backward. Zoom in a bit more. Moving forward with speed v naught. Speed v naught.
Right.
Data. Okay. And then the first sentence, part B. First, to note that the gamma factor associated with the value of beta is that. Okay, so if we take that,
Oh, it's okay.
I don't know if it's worth it to actually work this all out by hand, but actually, it's probably not the important part of the question.
I think there's another squared on that beta naught in the denominator.
True. Thank you. Scaldra's getting a little bit laggier and it's messing up the twos that I'm writing. That'll become a beta to the fourth. Okay, and then we also have a -4 beta not squared, so we can just make that negative. Oh, you know what? When I factored...
Yeah, that's good.
Oh, you put a negative 2. Thank you. Or a -1. Yeah. Let's just bring that up to the top. Okay, so that's how we get the 1 minus beta naught squared. And so this gamma, does it do everything? What does it do for us?
What does it do for us? That tells us and then it has to negative that gamma.
I might need another sentence here because I think we...
Yeah.
Yeah. The test charge frame, the test charge sees the positive ions. Moving backward with speed beta. Yes, the
Wait,
separation.
that part is...
Yeah.
We got that part on our own.
So separation is contracted by a factor of gamma, so the density is increased by a factor of gamma to 1 plus beta squared and lambda naught over 1 minus beta squared. That's just, okay, so that's what we have, like, right here, but they actually plug in for that gamma. But I guess the electrons that we're getting... Oh?
Is it that we just don't have contraction for the electrons because they were moving at the speed one direction and they're moving at the same speed in the other direction? So like the contraction is just like the same but the opposite direction, which doesn't matter. So
that
they just don't contract.
That
How do you feel about that?
feels right.
It does look like that might agree with the formula. Because I see the 1 minus beta squared's canceling.
Oh my, yeah, you're right, Stooky. The lambda naught for the electrons is unchanged.
Okay. I think I have
Um,
to spend some time thinking about that. Because
yeah, it's been so long since I've read the little appendix on relativity. I feel like I would need to reread it, or even better, just get an actual relativity book at some point, because I'm struggling with these constants. Are we supposed to get a common denominator here?
Sure, why not?
I don't see how else we would get a cancellation, possibly.
Yeah, ones cancel, 2 beta naught squared.
Squared over 1 minus.
I'm going to erase my answer because I think it was fluky and mistakeful.
Okay.
And we'll give you some real estate.
Um,
I had fun writing it up, even though it was incorrect.
It's worth a shot. What were we saying this two?
Yeah.
So we have 2 beta squared. So we don't have. Ooh. Can we somehow justify that this thing here is equal to gamma, beta, beta naught? Special relativity is always conceptually slippery for me. I feel like I mostly understood it when I read it, but it kind of immediately fell out of my head. So I guess I'm the same. I feel so similar. I think it might be easier to work with this side. Or to look at like what gamma, beta, beta naught is.
yeah.
So gamma we already said is 1 plus beta squared. Beta naught squared. Or 1 minus beta naught squared. Beta is 2 beta naught over 1 plus beta squared. Well, this looks promising. Times beta naught. So those two things cancel. And we do get 2 beta squared, beta naught squared, over 1 minus beta naught squared.
Oh, because beta, yeah, okay. It has the denominator. Got it.
Okay. So I like ta-da. Yeah, that's what the book does too. Okay. Well,
All right.
I feel less confident than ever when it comes to special relativity, but I think we mostly leave it behind after this chapter. Like, it's just used to explain why the magnetic field exists, but I think all the calculations they do, it involves some relativity, but not as much. Thankfully.
Yeah.
But, okay, so thank you for being here for another group.
Yeah. Thank you for pausing for another week. I think it really helped for me.
No worries. Don't want to like leave people behind or anything like that. It's like we're under time constraints, so yeah. I think I have some math questions to get working on, as well as Thunder's pressure questions. So,
Alrighty.
so see you both later.
Thanks, guys.
See you
Yep.
soon.
Bye.
See ya.
Okay. Let me switch gears here. God, those are some hard questions. Okay, let's switch the Twitch title and category. Every week I say that I'm gonna make a hotkey or some kind of more automated thing for this, and week I never do. Okay, Twitch time category updated. Update the YouTube title and category. And the YouTube thumbnail. Can't forget that thumbnail. Okay, YouTube's updated. Did I download the thing? The Excalibur. I did. I'm not ending the stream. I'm going to math help now for a little bit. Okay. Wave. So let's start with Thunder's problem. It's going to take some Googling. I need to get it on screen. So it's about pressure. Under pressure. Was group theory my undergrad? I had the option of taking it and I specifically avoided it. So for me, no. Okay. Tall smooth cylinder contains air atmospheric pressure of 1 times 10 to the 5th pascals. The density of air in the cylinder is 1.20 kilogram per cubic meter. Heavy piston is now placed on top of the cylinder and allowed to fall slowly downwards, compressing the air until the piston rests at equilibrium. The mass of the piston is 50 kilograms and its cross-sectional area is 0.020 meters squared. It's the density of the air in the cylinder when the piston rests in equilibrium. I think let's Google the exact text of the problem, because I'm sure there's a equation that... I feel like there's something more specific than PB equal than RT. A tall, smooth cylinder contains air at atmospheric pressure. Atmospheric pressure. Don't know how to spell. Of 1.0 times 10 to the 5th PA. The density of air in the cylinder is 1.20 kgm to the minus 3. Let's see how far that gets me. Chegg, no. University of Cambridge, yes. Oh, there's not gonna be an answer key here, is there? Oh my god. Cylinder. Okay, here's the exact same question. They call it number 20. Is there gonna be an answer key at the very end? Well, I know what the answer is. They're not gonna explain why. Ugh. Okay. It's apparently a pretty popular question. Oh, hey. This is what we want. Number 20. It is PV equal to RT, okay. I just wasn't really sure how to use it. So, okay, how are we following this person's work? They say that N is equal to M over something. Forgot to add the 100 kilopascals back to the 25k kilopascals. What is... Oh, that's a big M? I don't know what that's supposed... I don't know what N is supposed to be, to be honest. Is that like literally the number of molecules? I have to be honest, I have no clue what's happening here. You're saying that you forgot to do this thing on the right. I have no clue what's happening in this. The pressure arrow, I don't know, is equal to the P0 plus force over surface area, I assume? Yeah. And P0 we're just given. And then force is gravity. Okay. So that's the pressure, and then we need to convert the pressure. We need to use that pressure to figure out what the density of the air is. Is this a weird row? Is that density? It must be, right? Oh, and you have this proportionality. Huh. I think I'm going to send Thunder a screenshot of this. I think it'll make more sense to him than anything I can make. Okay, I just sent Thunder a screenshot. Okay, there's the one that Minority Suspect put in my Discord earlier today. I got back to them just in text. So they had this interesting looking problem where you have to find the volume of the interior of this kiln, which for some reason is uses a catenary. That feels kind of arbitrary, but sure. Oh, you know what? That might... I wonder if that has some weird property where it minimizes stress or something like that. Like due to gravity. Maybe there's some like property like that. And so it's kind of weird because you have to find the zeros of this catenary, and that's not really simple. You're told the density problem too late though. Oh, okay. Yeah, sorry, Felix. I feel like I wasn't gonna get that quickly, so I was like, okay, I'm just sending a screenshot. So yeah, this is the exact thing that I was thinking Minority Suspect should do. Let's work it out for ourselves. To verify the numbers. So from this, we'd say that equal to plus or minus inverse cosh of 3, which is terrible, but it's good enough to solve the problem with. One cross-sectional area of this is equal to the integral from, well, we can do what minority suspect to do twice the integral from 0 to inverse cosh of 3 of 3 minus cosh x dx. And who here knows what cosh integrates to? Hyperbolic trig derivatives. It is just since there's no sign change. Okay, yeah, you're right. Three x minus sinh 0 to inverse cosh 3. 3 times inverse cosh 3 minus sinh of inverse cosh 3. I wonder if you can simplify those like you can with regular trig functions. Either way, I would just use a calculator here, but let's go to trusty Wolfram Alpha. So we have 2 times 3. Ah, Suna. Thank you very much for the raid. Welcome in, everyone. How's your stream? Oh my god, I keep writing arc. Gosh, I don't know. I think that's also valid notation. Welcome in, everyone. 4.92, is that what minority suspect got? 4.92, yeah. Did it work? The raid? Yeah, it came through. Thank you for it. And so then we just worked out the two-dimensional area of like just this front bit. And so I was sketching the main PC crashes. Oh yeah. I forgot that's how your streams end a lot. Yeah. And so if we want to get the three-dimensional area that goes backwards here, I was saying that we need to do we need to integrate this area basically from 0 to 6 in terms of z, and it doesn't depend on z, so we're just going to end up multiplying by 6. Multiply. Yeah, that's what ends up happening. I'm doing like a bit of a fancier way here, but you just end up multiplying by 6. And they actually they don't give us a parabola. They're being difficult, and they gave us a catenary. So like a cosh and sinh, if you've seen those. I'll show the original problem again in a second here. 29.54. I get 29.52. That's just Wolfram Alpha versus whatever calculator this person used. But that's the idea, Suna. I first worked out like the area, just like the two-dimensional area in red here. And then to make it into a volume, I just multiplied by 6. So I'm pretty sure that's fine. There's like you could do this in like a multivariable calculus way too, but I think it's more like hinting at that than actually wanting you to do that. Yeah, I showed it the complicated way because there's situations where it wouldn't work if there was a dependence on Z, but in here it does. Oh, not dividing by 6, but multiplying by 6. Okay. Jeez. Okay, what else is here? Uh, yeah, I prefer both because some people prefer one over the other. I like a forum because it helps keep things separated. Because I noticed, like, I used to only have this math discussion channel, but even like now, there's like multiple conversations running over each other. If I like scroll a bit, like it's kind of like bouncing around everywhere, and it's hard to follow like one bit. Like there's this person's question here that I answered, but then like it's sandwiched between Lubert and Waffle talking about a combinatorics problem. So they're both helpful for different purposes, but so, you know, I feel like After Ranger was asking a really difficult question on Thursday. And I have a feeling that I can't do this question either. And that After Ranger is doing math that I probably can't do. I'm not going to ChatGPT. Yeah, the correctly part is the issue. Yeah, I don't know how to do that one. It seems like a Vietas thing or something. I don't quite know though. So, that's I just don't like ChatGPT. I guess I don't know. I don't know how I feel about AI in general. I just don't quite trust the companies that are using AI, or really any organization like government or companies. So I'm a bit weird about using ChatGPT in general. This is some crazy. I think this is a composition geometry problem that I can't do. This looks complicated. All right, so critical. I'll do one of these questions, or I'll look at one of these questions. You can choose one, but I'm only doing one. I'm not gonna like. I've already done way too many of your questions for you and just given you the answer, and I'm done. You can choose one and I'll try to guide you through it, but like I'm not just gonna work it all out for you. I'm just telling you what I'm gonna do, which is I'll do one, and I'm not going to do it without input from you as we work it out. So which problem do you want to look at? The fourth one? Okay. Oh, okay. I see you're putting the start of the text there. Okay, so positive charge Q equals 9.86 microcoulombs is spread uniformly along a thin non-conducting rod of length L equals 25.4 centimeters, where what are the magnitude and direction of the electric field produced at point P at distance R equals 10? So I remember you asked me a question before about the charge on a disk at the axis. Are you allowed to just use the result of that here? Oh, this is a rod. Never mind. Hmm. I think we have to do integration with Coulomb's law. We can't just cheat and use an already derived thing. Uh, basically what Dr. L says, it means that this line that contains P bisects this rod. It's like it cuts it in half. And that this angle is a 90-degree angle. Can Gauss's law make this easier? Yeah, two equal lengths. The Q here critical is spread out along this rod here. So this entire like rod contains 9.86 microcoulombs. Yeah, exactly. So I'm a little bit afraid there's a shortcut here that I'm missing, but we can definitely do this with integration and Coulomb's law. I would love to figure out a Gauss's law way to do it. Hey, student. The thing that I'm not sure about Gauss's law. Maybe I don't need to worry about it. I just don't know how like these end caps work. How does that flux work? Yeah, Dr. L. Um, if we use cylindrical, the rod becomes another cylindrical or just planar. I think we need to worry about the actual. Well, we probably aren't going to need to worry too much about the difference between polar and Cartesian coordinates, I think, when we actually go to solve this. There's only very few symmetries or Gauss law work. You can easily enumerate them. This is not one of them. Okay, I thank you, Dr. Ellie. I guess that's what I needed. So I was hoping that the result for an infinitely long rod would apply here, but it doesn't, and it only could possibly apply if this distance was way smaller. I think this is, we just have to bite the bullet and do Coulomb's law. Unfortunately. Okay, so I guess let's get working on it. I'm gonna make a copy of this so I can like doodle all over it more. When we want to figure out how to use Coulomb's law here, we need to just take an arbitrary kind of like little bit of this rod and figure out what its contribution is to the field here. So right off the bat, for any little bit of the rod we can name on one side, there's another bit on the other side that's going to like kind of cancel out the horizontal parts of their contribution to the field. I only expect a result pointing straight up, and no part of the field is going side to side because of this like symmetry. We're exactly halfway through. And so yeah, that's the answer to part B. Yeah, okay, I forgot about that. So that's an important thing to note here. We, for that reason, we expect this field to only point up like there. And we have a vertical distance r, and then this horizontal distance is what we're going to be integrating over. Off to dinner? All right, thanks for hanging out, Dr. L. Enjoy your dinner. And here for minus L over 2 to L over 2. Yeah, that's gonna be the idea, but I need to build up to that. I'm gonna take this as the origin. So this distance here is just x. Yep. It's gonna be that. Slow turtle. Then we can complete this right triangle. Just with Pythagorean theorem, the hypotenuse of this thing is r squared plus x squared. This is where like this little bit of charge that we're interested in starts. But where it stops, we have to go a little bit of an extra distance dx. And that's where like the integration comes in. Why is this? Yeah, this is, I'm using a mouse. You could also call this y squared here. But, and you'd be completely valid. It's just that, we're only, it's always a distance r away. Like we're pretending that that's just like a fixed amount. So we can just always use r whenever we would use y. Oh, Wacom tablet for 20 to 30. Yeah, I want to do that at some point. I don't exactly know what I want to like have my stream look like right now, so. All right, so we want to figure out how much charge is contained inside this little thing. Its length is dx. We can figure out lambda for linear density is equal to total charge over length. Here the total charge is 9.86 microcoulombs. The length is 25.4 centimeters. And so that's the linear charge density of this rod. If we want, how am I going to say this? Let's make this an actual number first. You're right. Let's just, yeah, let's not worry about the units yet. I like that more. Yeah, it will be that thunder. It's been a while since I've done that. Critical. I'll write it here, but we can just keep it as lambda for the sake of actually working out the integral. Actually, so this little like length of rod contains an amount of charge dq, like some incremental change in charge, and we can actually quantify that by taking the total linear charge density lambda and multiplying in the length that we're given dx. So I think we know what we need to apply Coulomb's law now, which is E sub y, because that's going in the y direction, is equal to well, I just say dE sub y is equal to some, so a small change in the field is equal to some small change in charge, which is the dq that we're talking about over here, over 4 pi epsilon naught. Oh, you might also use k instead of this. Not sure which one you're more used to, but times r squared. In this case, this thing right here is that, sorry, when I say r squared, I mean the distance from this thing to this point. And that's the hypotenuse of this triangle squared. Or it's the hypotenuse of the triangle, and then we have to square as part of the formula. So r squared plus x squared. We're not done quite yet. I would need one more factor, but because we're taking the component with respect to y, we need, all right, see you, student. Sleep well. I'm going to name this angle as theta. We already know that the x components are all going to cancel with each other, so we only want to care about the y component of this field. And to get the y component, I'm going to multiply this thing by sine of theta, because that gets us this part of the right triangle here. Yeah. And sine theta, sorry, I'm scrolling around everywhere. Sine theta is opposite over hypotenuse. So opposite is r. Hypotenuse, we said, is root r squared plus x squared. Drawboard? I've never heard of it. I'll have to look into it. All right, so now let's sub out what we found for dq and sub out what we found for sine theta, and then we're ready to integrate. So dq we said is lambda dx. And we know what this lambda is, but let's just keep it as a symbol until the end. Sine theta is r over r squared plus x squared. Okay, and so the actual electric field is going to be equal to the, you integrate each side of this thing. Integral dEy, which is equal to the integral of lambda dx over 4 pi epsilon naught r squared plus x squared times r over root r squared plus x squared. And these values range from this end, which is minus L over 2, because we're integrating in terms of x, and the origin is right here. And the other end is positive L over 2. So those are the bounds for our integral. Now we just have a, it's L over 2 because of where we're putting the origin. Yeah, because we separated in half, and we're saying the origin is halfway through. So there's L over 2 on either side of the origin. We could have put the origin like right here, and then we'd be integrating from 0 to L, but we instead put the origin halfway through. This thing is even? I mean, maybe. Oh, I guess it is. Yeah, that's weird. That's still, that won't necessarily always be true though, so I wouldn't base it only off that, but because you'll sometimes have an X up top there, so I wouldn't always do it like that, but there were funny symbols on the screen. The memes are true. Yeah. So I'm going to bring all our constants here and that are out in front of the integral because they don't have anything to do with x, so they can just come outside. And then we get dx over this can get multiplied with this. The exponents add. So you'd have having to integrate basically 1 over r squared plus x squared to the 3 over 2. That's an annoying integral. You have to do some trig sub that I don't know offhand. Because it's physics, I would use Wolfram Alpha or a table of integrals. Where? There it is. Okay, well, you can do it slow turtle's way if you really want to show all your work, but like, it's physics. We can just use a table. Let me it's an easier way to do this. It's Electricity Magazine by Purcell and more, and I'm doing a reading group on it that just ended an hour ago. So here, instead of A, we have R, but I'm just using the formula as it's written. Links are turned on in chat. Yeah. All right, so now we plug in L over 2 for x. Square over 4. The E&M Reading Group never truly ends. Yeah. I mean, it will eventually. When did I start it? I think it was in like May? Already scarred for life. I think I got a slow turtle. All right, so the denominators are the same, so we can just add these things. Okay, so then we can cancel an r with one of the r squareds. r squared plus L squared over 4 to the 1/2. Or you could also write that as square root. I'm just writing it as 1/2, I guess. Okay. So now we let's work out part A what the magnitude of this thing is. Remember, this is e sub y, but that's the only thing that'll have magnitude here. So for part A, lambda we said is 3.881 times 10 to the minus 5 coulombs per meter. What is the square footage of the ocean as an equation? I mean, I don't know as an equation, but that's one of those weird things that Wolfram Alpha knows. Surface area of the ocean. Let's see, 135.4 million square miles. All right, so the length L in meters is 0.254. Over. Definitely knew that too. Oh yeah. R. Do they not tell us R? Oh no, 10 centimeters. So 0.1. Meters times 0.1 meters squared plus L is 0.254 in parentheses squared over 4 square rooted. Only if I they only start earning if I go for much more than like 4 hours or something. Like, yeah, it's more like five or 6. Now, this is work for a calculator. Oh. So total, we do need to make it an actual value. They don't put, oh, okay, here it is. So you're right, I should have done that. Or yeah, you can also use K. Honestly, I don't really like K personally. Just use the entire thing. (8.85 times 10 to the minus 12 times 0.1 times 0.1 squared plus I have 0.254 over 2 squared. Making sure the open office is interpreting what I put in correctly. I think it is. So we can take this 5.48 times 10 to the 6. Oh, I wasn't showing my Wolfram. Oops. That's what I get, though. Newtons per coulomb or volt per meter, depending on your preference. Yeah, or you can make it 5.5 times 10 to the 6. The difference between epsilon naught and k, k is equal to 1 over 4 pi epsilon naught. So, no, we have 3 significant figures in the original problem. So you can always use one or the other if you want. Hold my polar watch this? No. So you could also write in this exact same formula, but instead of this bit here, you would have k up top. And it's otherwise the exact same. And then for part B, the direction is relative to the position of the x-axis. I guess you would say it's perpendicular to the x-axis, pointing in the y direction. How do we find that r equals 0.1? Yeah, because I just converted the 10 centimeters to meters. Sorry, Pankaj, I'm really bad at JE advanced questions. So yeah, does that make sense? Critical? Okay. Yeah, we figured out B at the very start because of the symmetry. This is what I said. Pankaj, I don't really enjoy those JE advanced questions. I'd rather do math that I enjoy. No, that's it. Critical. Just go to my Discord, see if I'm forgetting anyone. I don't think there's anything that I'm forgetting that I can actually do. There's some that I can't do in there, but... Yeah, critical, but you need to, like... I'll do one problem per stream from you, but you like I'm just kind of done solving a bunch of these in a row. What the heck is this? What are the brackets? Oh, they define it for us. Okay. Oh, it's like an approximation for the speed of light, yeah. I remember that. They were talking about magnetism. I think where was I? Because I'm currently reading chapter 6. I think I was right at the field for a solenoid. But I don't think I read any of this week, so I'm kind of rusty on all the stuff that I've already read now. Critical, no. You gotta rely on someone else. Take a computer guy. Hmm. I'm debating. Ooh, I know what I can do. We were just doing the physics reading group for the first 2-ish hours of the stream. We just answered a physics question from Critical, and now I'm going to move on to problem from Zach's Infinite Series class. I'm trying to find it. Here we go. No worries, Critical. Oh my gosh, you teach college students or schools of... I'm not a teacher. I've been a tutor at a community college, which is like just after graduating 12th grade. I'm not an actual teacher though. I've also have tutored like privately. Tedious prompt, partial fractions is a good idea. I was challenged to do this problem by Zach. And I'm not one to back down from a challenge. Now I don't quite know how we're going to get an exact sum for this. Oops, oh my god. I'm gonna get mixed up with... I'm making these x's. Top doesn't factor, so we don't get any cancellations. Wait, oh, okay, that has to be a typo. That must be a V. Because there's no n to anywhere in the problem. Oh yeah, we saw the same thing. $10. Although I'm making them into x's now just because I'm going to forget to write v and I'm going to randomly switch to x halfway through, I feel like. So, but just, you know, rip the band-aid off. Wait. Zach says a computer algebra system might be helpful. You know, let's not... Okay, we don't have to do partial fractions by hand here. If Zach is going to give me an out, I will take an out. Hope and computer guy, I hope you're doing well today. 2v plus 5, 2v or not 2v? V plus 4. Ooh, that's a funky graph. It makes sense though, it has a lot of asymptotes. Here we go. Aha, get wrecked problem. So actually, all right. Analysis indeed. I take a day off feeling a bit better. Oh, geez. Glad to hear that you're feeling better. Oh, the only way this works is if it's telescoping, right? Because you only really know the sum of, well, we can only easily know the sum of something that's telescoping or geometric. If it's not one of those two things, you have to do a lot of work. But maybe this is a lot of work still. Should we take some values of v here and see what happens? Like this. Ooh, this should telescope with this, and this should telescope with this, I think. And yeah. How should we write this to make it the most convenient? Maybe v equals 1 to infinity. Take that piece first. It's too small for me to click and drag it. Plus that. Okay. And so I think I'm just going to plug in B's until the telescoping starts actually happening. So if v equals 1, we get minus 1/6 plus 1/15. Factor out the 1/3 and the 5/2. Oh, true. Yeah, good call. We'll do two separate sigmas here as well. Remember, I factored out a negative 1/3. Okay. So for telescoping, we should only have to go like 3 terms or something before it starts actually happening. So we get 1/2 minus 1/5 plus 1/3 minus 1/4 plus 1/4 minus... Wait. Why is that 1/4? Why did I put 1/4? I was getting too far ahead of myself. A 6. A 7th. There we go. And so... Okay, we need to get to a 5th. Plus a 5th, and now we're telescoping. Separate the sums and make the change of variables for the summation of index. A change of variables, really? Oh, for the second one, that could speed it up. I had mentioned for the first one, it wouldn't help. But another thing is we have a minus 1/5 and a plus 1/5. And I'm gonna... I think we claim that the 1/2, the 1/3, and 1/4 never get canceled. Everything else will. So that'll cancel, that'll cancel, that'll cancel. I'm bringing the summation to make this part right here easier, Pankaj. What will the change of variables even look like? I'm kind of going to just do it the old-fashioned way. It should only be like 1 or 2 terms, right? 1/5 minus 1/7 plus 1/7. Oh, yeah. That's a 9th. That's gonna cancel. We get the... It starts telescoping immediately. You can do it without breaking the summation, but I think it's easier if you do. There is no last term here because the limit of these as they approach infinity is 0. Yeah. It's times a 5th. Fraction math. Dinkelberg. Okay, we need to bring them all to 12. So that's 6 plus 4 plus 3 is 13. It'll be plus 18.5 over 36. Is that what we're supposed to get? Hey, there we go. A little help from Wolfram. We got there. I'm from America. All right. Well, I'm glad we used Wolfram there. So I think he also said there was one from the 5th. That one's from meeting 4. There's also one from meeting 5, so that might be good to look at, I think. Oh yeah, he wanted people to do Zach's favorite theorem. And I think I see like how to do it just all in my head, but we can show it out here. You know, a couple of the other ones look like they might be cool too. Zach's favorite theorem. For any polynomial that's not equal to 0, prove that the limit of p of x plus 1 over p of x equals 1. So I think you need to actually make these polynomials. So say like a1 x to the n plus a... I mean, we don't need... But I guess we do need subscripts, yeah. Never mind. Cn minus 1 plus dot 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 plus a sub n minus 1x plus a sub n over b sub 1. Oh wait, it's the same thing. Oh, I'm doing this wrong. I just wrote the denominator. We don't need the subscripts. Well, it's too late. I'm gonna use the subscripts. Actually, the subscripts are nice. Okay. And so now, we could do a L'Hopital's argument, but I think a simpler argument is to multiply it by 1 over x to the n over 1 over x to the n. Because you can say that this thing becomes 1 plus 1 over x to the n plus a 2. What happens to this thing? I know it should be 0. I need to justify to myself why. Like that? Oh, wait. I see the problem. It's part of the problem. That's just x, not x to the n. And this does indeed go to 0. Okay, good. Because this bit goes to 0, so we get 1 over infinity, which is 0. Do a Minesweeper? Okay. Once we, or once I just finish writing this out. And I'm nearly there. Ugh. Over a1 plus a2 over x plus dot 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 a n minus 1 times 1 over x to the n minus 1 plus a n times 1 over x to the n. Now we can think once x goes to infinity. And I think we've justified that it's a1 over a1, which equals 1. Provided we have a non-zero leading coefficient, I guess. It's a pretty safe assumption. That's what you meant in general? Oh, yeah, let me look at that before I do the Minesweeper. Because I'm sure there is a change of variables you can do for that summation, but I wasn't really... You know what, let me, I have a better idea. Can omit some steps, obviously, but that's the idea. Oh. I like that. Because that's what I was trying to... That's kind of like intuitively what I figured out in my head. Like, we have to go 3 iterations or so before it'll actually start to cancel. That's a really nice way of actually showing it, though. I like that a lot. There's no informal expressions like the dots. That's true too. Yeah. I know those dots are technically like bad form. Like they're like a hidden proof by induction that you're not actually doing. Ellipsis, yeah. All right, let's see if I can actually do a Minesweeper unlike the last time I tried. Oh, I'm stuck. I have to send something. That one. Oh, hey, we got lucky. I'm stuck again now. That one? Okay. I'm still stuck. I should have sent a more helpful one. I'm getting really lucky, oh my god. No, I misclicked. I meant to click on the one to the left. Oh my god. Misclicks are the death of me, man. It's what ends, like, way too many of my Minesweeper runs. Fuck, I misclicked again. I was trying to click that one. Oh my god. Not if I keep misclicking. I'm better with my thumbs because I play it on my phone. This is also why I have terrible mouse accuracy when I play shooters. Wait, oh no, I misread. Okay, that was an I just actually fucked that one up. I misread the numbers, so I'm going too quick. Hmm. Could you give me your 20s? Oh, nice. I'll actually flag things. Because I'm stuck anyway here. Probably make someone happy. I don't know. Okay, that was just a guess and I got lucky. There we go. Now I have something to work with. One of your math puzzles? I guess so, sure. I guess a lot of time I just like don't get a ton of enjoyment out of puzzles, but I'm curious to see what angle you take with one. Oh. Oh my god, that I didn't mean to click on that one, but I got lucky. Oh my god, I finally did one. Don does math. Where am I? Oh wow. 49 seconds? Alright. Ben, is this a new low for Don? Nah, this is a new high. Minesweeper is all the rage these days, Ben. You just watch. It's like, oh, 9% people can't solve this junk. Yeah, I mean, I'll be take a look at it. Like, if we were put in the chat or Discord, or I don't know what's easiest for you. Let's talk triangles. Like the type that you surf on, Ben. Perhaps. Oh. I probably shouldn't stream for a ton longer, but I'm gonna need some food. Oh wait, you know what, Ben? I just remembered. I've been meaning to ask you. Can you try inviting me to Deadlock? Because I literally just never got it. Like, never got to my library when the other Ben added me. I wonder if Valve just doesn't like me. You don't know? Okay, he did it from somewhere like in the game. It was just like brought up his team for friends list. Apparently, anyone who has it can invite others. Like, you go in game. Like, I was seeing Ben's screen as he invited me. You just open the game, and there's some like way to invite other players from your Steam friends list in the game. I don't remember exactly where. If you can't figure it out, it's fine. Random numbers, you get the answer up front. Okay, it's just basic math is all you need. Okay. It's a pyramid scheme? Yeah. You recruit 10 people, and then they recruit 10 people. Streamlabs looks different. Yeah, for at least for a little bit. I'm just gonna be using Paint, so I made a new scene. Whiteboard just a little like too much of a pain. Oh. I think I was gonna do something with my friends tonight, but I can potentially surf for a little bit. I can't. I don't know exactly what's going on with them. What's up with number 9 on this page? Prove Abel's theorem. Given any sequence chi sub n from n equals 1 to infinity is greater than or equal to 0, and it's monotonically decreasing. If chi sub n converges, or if the sum converges, then the limit of n times chi sub n equals 0 as n goes to infinity. What does contrapositive mean again? I always forget what those, like, there's inverse, contrapositive, something, 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 something. I don't know. Contrapositive meaning. Math words. Switching the hypothesis and conclusion of conditional statement and negating both. Ah. If the grass is not wet, it is not raining. So P is the same as Q as if, okay, yeah. So if the limit of n, oh god, I need to fill that in. Okay, you know what? Never mind. No typing. Limit as n goes to infinity of n chi sub n not equal to 0, then n equals 1 to infinity chi sub n diverges would be the contrapositive. Oh yeah, okay. So let's make a computer guy's puzzle first. Solve for 289. Yeah, how do we solve for 289? Like make them add up to 289? So I can only use them each once. So like I could do like I might be able to, you might not. Well, can I use the same one multiple times? Okay. So then 75 one-time use? Okay. So like if I did like 75 times 4, what is that? 150 plus 150 is 300. Well, I'm nearly there. So I need to make 11 with 5 and 3 ones, which seems like a tough ask. I see that Femlox puts something there, but I'm trying not to look at it. Oh. We can make an 11 here. 75 times 4 minus 5 times 1 plus 1 plus 1. So we get 300 minus 5 times 2 plus 1, 289. Okay. Infobox said the same thing. Nice. Okay. That's a lot nicer than the ones that like make you go on like a whole scavenger hunt around like that's like they take a lot of time and end up being like as like more tedious than fun to me. Thank you for the little puzzle there. Yeah. Cool. So out of this bit here on the left side, this means that chi sub n is greater than or equal to 1 over n for this to be true. Oh, and that just gives us the comparison right there. So, okay, that actually was a lot quicker than I thought. This is by the comparison test. I see then diverges. The test is purely meant to try and get your mind at a ruts. Oh, okay. Yeah, it's not the same exact thing, but it reminds me a bit of Nerdle. Like it's like a similar type of just like little like brain teaser that's not insanely difficult. Like it's just like Wordle, but with like a math equation. Yeah, but it could be any true math equation rather than having to make a certain number. Zone ranges point out potential issue here. Chi sub n might not always be larger than 1 over n. Well, I guess, can we say that it should eventually be larger than 1 over n? For some n greater than or equal to big N. And then we'd say, would we even have to edit this to be big N? I guess it'd be for all. Where N is something that we choose. Does that address the issue that you're pointing out in Zone Ranger, or is there something else that I'm missing here? Kaisaben. Oh, at least in the construction of the problem, we're given it's always positive, but I wasn't scrolled up to include the original prompt. Could we still address that situation though, where it's negative or alternating? Is this like a version? What is Abel's theorem? Is it like a general version of Abel's theorem that applies to? Oh, it's that Abel, of course. a negative series or alternating. I assume it just wouldn't hold for alternating. I feel like an alternating sequence could still converge. Yeah, the idea from British show Countdown. They have a math section where the players have 30 seconds to solve like what you did. Ooh, wow, I have to study for that. Like, that's an interesting question, though, Zone. I wonder what happens if we do consider other versions of this. I think for negative, we can make basically the same argument, just make a different case for chi always negative. So it's just, it looks like this is setting it up for any convergent sum. A little easier, no time limit, yeah. Is there still a cash prize though, or you know, what do you get on Countdown? Oh, BRB. Never mind. Why did this looks different from the Abel's theorem that Zach gave? This is a power series. I assume there is a version of it that we don't have to care about being strictly positive, but yeah, actually they're doing some alternating series stuff here, but I suppose the class we don't all have to go there right now, I guess. How do you do number 7? I don't see how you would solve that inequality. Like, where do these two things equal each other? There's no way we can like that like prove the results is what's holding me up here. I could certainly plug it into Wolfram Alpha or Desmos and find the result, but that's not a proof. Oh wait. Well, we're given. Well, that's kind of cheesy. If we're already given that it's true for all positive x's, we can just do a test value. Which feels a little bit lame. But like 1 is a convenient test value. The alligator eats the bigger one. And I mean, the same thing is true, like, down here. Is the 5th root of 1, 1? There's no trick? No, yeah, it's still 1, okay. And the generalization is ln of x is less than x to the 1 over n. Where n... Oh, well, we should say, where all x belongs to 0, infinity, for n, I guess, natural numbers minus 1. I guess I was taking this bit as a given. Like, I know. It's not a real proof either, but like, if we're just given that it's true for all x's, we could just plug in a test value. But like, well, like, I don't know how we do the more interesting version of this problem where we compare, or we find where ln x and root x intersect, unless there's a different way of doing this. That doesn't involve power series, because we haven't gotten there. Calculus, would that help? So this is from Zach's analysis class for a series. So we could use, like, can we make some argument about the derivatives? Oh, wait. Can we do limit as x goes to infinity of root x over ln x? We can do that too, Anders, yeah. I don't know how, like, where we go with that, but we can. I think this might be the point. So we did talk about doing this sort of thing a lot in the class. So I wonder if this is what Zach was intending, but I'm interested to see the sign of f prime says which is bigger. Oh, really? It says the actual function value is bigger? I guess so. Or wait, Let's think about that. I think this Sloppitles thing would work too, but now I'm occupied with Andrew's argument here. Maybe more clear for the common denominator. I think I could work this out as well, but I think we could make an argument like that, Anders, if we check some starting point. Like, if we checked the origin, like we checked x equals 0. You can find the critical points. Oh! And that's where they intersect. Right? No. What does the critical point of this thing mean? Does the critical point help us? We can find them, but I don't know how, like, what that does. Hey, computer guy. Working on this problem now. I did a proof by doing a single example, but we're working on an idea for an actual proof. We define the function of one function minus the other one, and we take the derivative of that. What does that mean? I don't think that means all that much. The critical points don't help us find. I mean, so what we really want to find, or we want to determine either like what would be helpful, or like I'm just imagining like if the function, if this function here looks something like that, like how does knowing the location of that help us? I mean, you might be right, I just don't know. What we could do is I think it's almost like a differential equations argument that we can make here. I mean, it's not really differential equations, but if we can determine when this thing is positive, or like it should always be, actually it should always be negative after a certain point, right? If we can figure out where it starts always being negative, that's potentially something. The denominator will not affect the sign, so we can make it into this problem. 2 root x. Well, how do you deal with this? It's annoying, that's what it is. I guess we do this and we square each side, and that's safe because these are positive numbers. So from 4 onward, the derivative is always negative. I think we can I think we can construct what the graph of this thing must look like from that critical point and knowing what the sign of the derivative is. So we have a critical point at 4. And f of 4 is equal to ln 4 minus 2. That's, I don't know, is that's negative, right? We can Wolfram alpha that much. Ln 4 minus 2, minus 0.61. Okay. Is that right? 4 is more than E. Oh yeah, but it's minus 2. Yeah, okay, never mind. Okay, so we have the point. One, two, why am I making it so close? 1, 2, 3, 4. If that's -1, then we have this point here and we know it's a critical point and that it's a minimum. No? Is it a maximum? I found where the derivative is negative. So this is a maximum? That's weird. ln of x is greater than it. Well, it might stay negative. That's what we need to check. We can't check 0, 0. Oh, that kind of throws a wrench in it. I wanted to check the origin and then argue that I was going to hope that it will be negative at x equals 0 and argue that we can never become positive without making another critical point. But we can't do ln of 0. So that this argument doesn't really work. And we can't just do like 0.1 or 0.001 because what about a smaller number than that? Okay, I think I have to throw this argument out. Yeah, it is a maximum, but... Oh, wait. Actually, Zomer's making a good point. If we know it's a maximum, that's... Oh, yeah. I'm thinking about this way too hard. It's a maximum. Nothing can go above this line. The function has to exist somewhere down here. So I think that actually... that means ln of x minus x is always negative. For all x. So root x is greater than ln x. For all x on 0 infinity. Right, because the maximum of the difference is negative, so it can never go positive. Yeah. Punching, you require math assistance? Yeah. Let me know. You host it in Discord, just like tell me in chat once you do. Okay, neat. I think I would consider that a proof, but I also want to investigate what happens with this limit thing that I set up. It should be pretty quick. This isn't a proof for all x though, the more I think about it. It's only a proof in the long run. So in the long run, we expect root x to outperform ln x, but that doesn't work for the question asked. Okay, I see Punching posted a question. Thank you. So you put IBP in the title. Is this gonna be integration by parts? I would believe it. Let's try it and find out. So we're gonna need to take the derivative of arctan. That's not so bad though. And then dv will be the thing I integrate. We'll set equal just to dx because there's an invisible 1 being multiplied there. So if we take the derivative of u, we get 1 over 1 plus 1 over x squared, like that, I want to say, times the derivative of 1 over x. So minus 1 over x squared dx. And then v equals x. Okay, this seems like we'll get something that's possible to integrate. First, before we plug into the use of formula, yeah, that's going to be a helpful simplification to make. Dx. Okay, so now we do uv minus v du. So x arctan 1 over x minus integral. Oh, and it's minus from the formula, but minus from that, so we get a plus. X over x squared plus 1 dx. And then this is just a u sub. So u equals x squared plus 1. Du is equal to 2x dx. So you got perfect. arctan 1 over x plus 1/2 1 over u du. Ln of x squared plus 1 absolute value, and we have to remember that we had bounds here, so from 1 to root 3. So starting with root 3, we get root 3 arctan root 3 over 3. Just mentally rationalize the denominator there. 1/2 ln root 3 squared is 3. 3 plus 1 is 4. Minus 1 times arctan 1 plus 1/2 ln 1 squared is 1. 1 plus 1 is 2. Arctan of root 3 over 3, or 1 over root 3. Do I know my unit circle? It should be pi over 3? Because we want y over x, and y should be root 3 over 2, and x should be 1/2. Wait, no. Pi over 6. It should, we want the root 3 over 2 on the bottom. Wait, do we? Yeah. Yeah, okay, it's pi over 6. 1/2 ln. Oh, there's a little trick here. To simplify it a bit. 1/2 times ln, we can bring that 1/2 inside as an exponent on the 4. And the square root of 4 is 2. So we get ln 2. Arctan 1. And I'm doing this because we have an ln 2 over here as well. Arctan of 1 is pi over 4. Minus distribute the negative over here. Ln 2 can just stay as is. And now we just do a bit of cleanup. You got the same thing for that? Okay, good. Root 3, I root 3 over 6, I don't know. Ln 2 minus 1/2 ln 2 is plus 1/2 ln 2 minus pi over 4. So it sounds like you, where is your issue with this? Because it sounds like you worked out at least pretty far into the problem. Is there a part that oh, you just like messed up at the end, maybe? On simplifying the arctan? Oh, like... Okay. X cubed. Your second integral. Oh, okay, yeah, that'll do it. Yeah, sure, Anders. What does Wolfram Alpha say the answer is? That's root 3 over 6 pi minus pi over 4. That's just what I got. Plus 1/12 log of 64. Is that equal to 1/2 ln 2? 1/12 ln 64? There's a simpler way to tell. 0.468075, 46808. Yeah, so they rounded. Okay, it's the same answer. I don't know why they would 1/12 ln 64 isn't clearly. Is that root 2? 64 to the power of 1/12. How does that work? I'm just curious what the hell Wolfram Alpha was doing with this part. $64. We can. Does it have a 6th root? I guess that's what we would want. 64 is log 2 to the 6 log 2. Oh, that's a way nicer way of doing it. Thank you, Zone. I was about to do like 64 to the 1/4 to the 1/3, and that was getting stupid. Okay. Using Mathway and ChatGPT to get answers in standard form. Yeah, no, I mean, I would just turn this way. So I was just trying to verify that it matched what Wolfram Alpha gave. I mean, I guess I put the minus pi over 4 in front to group the pies together a bit, but it's the right answer, and you can mess around with it as much as you want, but ooh, I see your integral enders. So is this okay with you now, punching, or are there any questions, or? Okay, nice. Take a look at the integral that Anders put in. I don't know why Paint added on the extra black box. Now it's gone. The integral from 0 to 1 of x times the floor of 1 over x dx. So I think, oh, wow. I was going to try to do it geometrically, but 1 over x between 0 and 1 hits every real number higher than 1 and including 1. So that's not going to, oh my god, Anders. That emote too? Huh. This feels like a... Huh. What? No. Yeah, we can use Desmos. For this problem punching? Either you're a genius, or maybe do you know what these bars mean? No, it's not for parentheses. No. It's the floor. Be a much easier problem if the... What? Whoa, that's such a cool function. Wait. Why? The picture I had in my head was completely different. That's funny, it zeroes out after 1 as well. Could just as well be this integral from 0 to infinity. I mean, assuming the graph is accurate, I guess. So... Okay, I think we need to work from 1 to 0. Nedge? I'm not sure. I have for your name to be said, but thank you for the follow. Welcome in. Okay, so we could split this thing up from the integral from 1/2 to 1 of x times that dx plus 0 to 1/2 x 1 over x dx. And this we know how to do. So let's I guess let's do that and hope for we can see. Well, okay, no, well, we can split up a couple more. We can split up for every integer. Oop, not plus. This will be 1/3 to 1/2. Dx plus, oh, that's a terrible integral. 1/4 to 1/3 x floor 1 over x dx plus dot dot dot. So I think we do these couple of integrals and see if there's a pattern that jumps out at us. So 1/2 to 1 of between 1/2 and 1, the floor of 1 over x Why am I getting stupid here? The floor of 1 over x between 1/2 and 1. Isn't that 0? But it shouldn't be. Like I'm trying to justify why it looks like this section of the graph here. If you take, I guess 1/2 is a breakpoint. I should actually be using like 3/4. 1 over 3/4. Oh, I think I see it now. Yeah, it should be 1 because it'll top out, well, I guess we can do that inclusive, it doesn't matter. 1/3. Like, I'm just doing an example. I have a hard time really saying it in my head, but like an example is like, if x is between, oh, that's such a nice way of saying it, Anders. Thank you. That's the explanation I was looking for. Oh my god. Okay. If 1/2 is less than or equal to x is less than or equal to 1, then 1 is less than or equal to 1/x less than or equal to 2. Okay. They can change variables to avoid dealing with fractions. True. Yeah. There we go. And if we take the floor of this and we chop off that, is equal to 1. There we go. That's what I wanted. Because I want to justify that this thing just becomes that in this first one. That little trick I definitely needed because it's going to come in handy for all of these integrals here. Effie, I'll be useless at this. I did horribly at maths in school. I mean, that's a pretty common feeling. I have a lot of fun doing this. I'm sure there's something that you could stream on YouTube that you're good at. Over here, we should get 2 now by the same logic. So 2x dx plus the integral from 1/4 to 1/3, 3x dx plus ... So that feels helpful. We could actually go through and I guess we could actually solve these integrals. I don't know if we actually need to, but if you're really good at math, I can see why you find it fun. I mean, I wouldn't even say that I'm really good, but I'm good enough to have some fun with it. One-third to 1/2. Who posted that? Oh, is that your YouTube account, Anders? The classic self-troll. So it's a half. See what actual numbers we get. Like, it wouldn't be an actual proof, but if we could just like find a pattern in these numbers, that'd be pretty cool. Three over 2 times 1/9. 1/18? No. Three over 2 times 1/9 is 1/6. Minus 3 over 32. It looked really nice for these first ones, and then the last one just ruined a potential pattern. I was about to hope for a second that it would be telescoping because of the 1/2 and the 1/2 and the 1/3 and the 1/3, but it doesn't work out because of the coefficients. All right, so there's no obvious pattern from working out the first few. BRB? Okay. But these are trapezoids. Can we get the area of these trapezoids? How would that work? It's basically what I have here, I guess. Like, these first two things are the area of the first trapezoid. 3/8. Group these two fractions. 5/36. Six and 32? That's mean. Wolfram Alpha, away! 1/6 minus 3/32. 1/6 minus 3/32. 7/96. There's got to be a geometric interpretation. Well, there obviously is a geometric interpretation, but like I got to be able to figure out like how that works, because like we're summing up infinitely many trapezoids. Like the first one is that trapezoid there, and then we have another trapezoid right here. Is this a? Can we make a series out of this that's hopefully geometric so we know it's sum? Yeah, I think I know this formula offhand, but let's just get it. A plus BH over 2. You're not sure if the series turns out to be geometric? Yeah. I'm gonna see if I can write it out and see if there comes out to be anything helpful, but it might not be a series whose sum is easily known. Then how would this look? Like n equals 1 to infinity. How do we work out what this is with respect to n though? It would be 1 over n plus 1 over n plus 1 over 2. Is that even right? Because it's 1 plus 1/2. Say about your bike project? Oh, actually wait, one of these heights is always 1. And the other one is not. Ooh. Yeah, your bike project to power your computer, right? Oh, Maxi! Thank you so much. Lunibs, welcome in. Andreas, thank you for the follow. Max Wattage, hey, welcome in, everyone. Maxie, I hope your stream was good. Oh, it's Saturday, which means you were sipping, right? It was a good time. We were very, very good. That's good to hear. I was sipping. Nice. Love to hear it. We're just working on this little challenge integration problem from Anders in chat. Involving x times the floor of 1 over x, and I've had part of an idea, but I'm still like trying to work it out. In range bound, can you ask a question? Sure. If you would put it in chat, or I have a Discord too. Oh God, math, my eyes. Yeah. So for anyone who's new around here, I'm Don. W3W3 sis. Thank you for the follow. And I do actually like math help streams like this. Right now I'm just using Paint because I'm lazy, but I do have Whiteboard too. Then I also do some game streams. But right now it's math day. And so okay, yeah, so think about this integral. I graphed this function here. And it looks like this. It's a pretty cool looking graph. Fallout New Vegas? Yeah. The NCR flag. It's my favorite game. And so I worked out that we can break the integral up based on integers. So we can do an integral from 1/2 to 1, from 1/3 to 1/2, 1/4 to 1/3, and so on infinitely like that. But I didn't get an obvious pattern in the results when I actually worked out the first couple of things. Yeah, it's a pretty neat problem, it looks like. Something harmonic series. Yeah, it is a harmonic series. Like there's like 1 over x inside it, so there might be a harmonic series connection here. So the first few areas, like from 1/2 to 1 is 3/8, and then you get 5 over 36, and then 7 over 96, which actually the top does have a pattern. Those are just odd numbers. The bottom, is there a pattern? 836. I'm gonna cheat. OEIS, save me. 83696. Number of possible rook moves on an n by n chessboard. No. Oh yeah, I mean there's a pretty good Fallout merch store. Is Google gonna show my location on Google app? Let me just bring that up quick. Oh no, it won't. Let me oh dude, there's Christmas stuff? Oh, I shouldn't have brought this up. Deny. Get out of here. Dude. Oh no. They've added stuff since I looked at this last. They've added so many stuff. Oh, there's even stuff from the TV show. Yeah, it's only $16? Huh. I don't remember how much I paid for it. But there you go. For the low price of $16, you too can have a new California Republic flag. They used to have the other version of the Brotherhood of Steel flag that was more like a triangle. I don't see it now though. I was going to get that because I actually like the Brotherhood of Steel more. But like I'm in California, so I was like, oh, I should get the NCR flag. There goes next month's food budget. Yeah, I kind of want all the things here. That bottle cap case I like too. We're down the rabbit hole. I love merch, dude. I have to try really hard not to buy like all the merch that I see. Oh man, I thought you'd be able to buy the mini nuke launcher. It's just the figurine though. Okay, that's kind of sick. Anyway, work moves, I buy it. Okay, I mean, I guess I would need some more terms before this actually helps. So what else can we do with this thing? International stars and oh no, that sucks. What is the width of each intervals? It's a half, a third, a fourth. So times 1 over n plus 1. So my other idea just for you all gamers, so is try writing this thing as a summation of the areas of trapezoids and just seeing if that happens to work out to something helpful. I think this form that I found on the left should be accurate? Question mark? I think the answer is pi over 12? Of course pi comes up. How does this thing simplify? Pi squared over 12, Lubert got. Okay. That feels like the 1 over n squared series, Basel's equation or something. How does this simplify? What actually really helped me to understand math was that it is all just functions. All those special symbols are just functions with variables. My mind was blown that day. Oh yeah, like sin x or log x, like all these at the end of the day are just mapping the same inputs to different outputs. Yeah, it's kind of a weird thing where like a lot of classes try to emphasize the fundamentals like that, but at least to me they didn't always do a very good job at it. The F kind of looking thing or the E kind of looking thing. F kind of looking thing or the E looking thing? You mean just like a regular like f of x thing? Like, yeah, I mean, that'd be like the exact same too. E oh, sigma! Yeah. That's a Greek letter, sigma. Capitals, sigma, I guess. Yeah, no, I get it. Yeah, exactly. Yeah, that too. It just spits out a value, or infinity, I guess, but... we can factor out a 1 over n plus 1 out of this, and that's how we simplify it. So we get n plus 2 over 2n plus 1 squared. Well, that's not helpful, and the sum diverges, so it's doubly not helpful. Okay. What the hell do we do? How does pi come into the equation? Am I overthinking it? Is there just like a simpler representation that we can directly integrate? Wait, could I integrate this series from n equals 0 or from n equals 1 to infinity? It should diverge though, right? It does come from 1 over n squared? Okay. You know, I'll let Wolfram Alpha do this integral for me because it looks terrible, and I think it diverges anyway. So there's a connection there, I guess, then. 1 to infinity. X plus 2, 2x plus 1 squared. 2x plus 1 squared, x plus 2. Yeah, you diverge. So I either set it up wrong or this is just not it. Or both. Sum of squares, huh? Yeah, please do, Anders. Start with u equals 1 over x? Okay. That was something clever, Freefall? Okay. Feel free to hit us with it. U goes from 1 to infinity. Oh, I did flip the bounds. Yeah, you're right. When I shouldn't have. But I can use the negative sign to flip them now. If we get the graph function from 0 to 1, you take each slope, tilt it to be flat instead, same with a bunch of rectangles. Oh, there might actually be something to that too, where you could subtract the length of the triangles. But yeah, with this change of variables, now you can split the integral. Oh, the same way. Okay, I have room below to do this. So yeah, we'd split it by integers still. So 1 to 2, u floor u. Okay, so the first one is still just the integral of u, so 1/2 u squared to 2. 2, so that's just u squared, 2 to 3. Oh. I guess maybe it's better to put that as 2 over 2. Maybe that's why I was getting a little bit confused as well. Two times 3 plus 2 times 2 times 2. Oh, well, as I'm making the claim between 1 and 2, the floor function is always 1. So I'm just treating it as a multiple of 1. Then here I'm claiming it's always 2. Here I'm claiming it's always 3. So that's where these coefficients here come from. You know, I don't think we're... Let's just actually multiply these. I didn't do that one right. 4 minus 1 plus 18 minus 8. 3 times 16 is 48. Minus 81. I'm still not quite seeing it here. I assume from knowing what the answer is that this thing inside is pi squared over 6. But it does not look anything like the sum of 1 over n squared. Group, again, the sum. Before using... I never heard of Barrow's rule, but I guess... Let's see what Barrow's rule is, because I don't know how to group it. Oh. Fundamental theorem of calculus? Oh, okay. Oh, so you're saying before I do this, like before I do this or even this, curve again the sum before using Barrow's rule. Oh. Well, no, these aren't always the same thing. So we get this thing. And I'm resisting the urge to integrate these. But we can't group these integrals directly. We'd have to do some finessing or something. Sum from k equals 1 to infinity. I need to cosplay a LaTeX render right now to figure this out. K to the power of k plus 1. Kudu? K U D U. What? Is this the next line? Like, this sum of integrals is equal to this sum? Oh, okay. I'm still not sure I see that, but... Wait. Oh, wait, I'm misinterpreting you. Oh my god, shoot. I was interpreting int as the floor function because I'm thinking about it in like programming terms. Yeah. Yeah, it's an integral in there. It turns out I'm a pretty crappy LaTeX renderer. K equals 1 to infinity. From k to k plus 1. K U D U. Sure. Kudu. Oh, and we just know how to do the inside integral? Now we get to evaluate it? Or am I jumping the gun? No, 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 no. Oh my god, this is the sum of squares, or it looks like the sum of squares, or maybe not. Actually, no, 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 no. It almost like the formula for the sum of squares. Really? Is this sum not gonna, like, the area of one of the trapezoids? Same with an infinite number of those trapezoids. Yes. Why is my sum blowing up to infinity? I guess, oh, there's, no, never mind, it's not necessarily blowing up to infinity. This is going to turn out to be a quadratic? Because the k cubed should cancel. So if I factor out a k over 2, we should have 2k plus 1. That's gonna go blow up to infinity though. Is that? No, 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 no. It's not plus 1. I think it's just 2k. Because there's a, no. I should not do mental math. Maybe that's the lesson to learn here. Just do it out the hard way. 2k plus 1 minus k squared. So it is 2k plus 1. My sum isn't right. Like, this is a... This is diverging. An error in the first step. I have not used substitution. It should be dx equals 1 over u squared du. If u is 1 over x, I think the sub was okay. Or apparently not. U is 1 over x. U to the negative 3? Did I mess this up in plugging it in? I don't see how. Oh, you have to flip it back. I see now. Okay. Ugh. It's because I didn't... It is negative x squared over here, but I converted the x back to u, so it should be flipped. Okay. Ugh. Okay, at least... Now we know. Well, you all already knew. Now I know. Okay. So what do we get now? We get minus 2 k 1 over u squared 1/2. I think so. K over 2 times 1 over k squared. Okay. But one of those diverges. What am I still doing wrong? It looks good? I'm seeing on the right there's a harmonic series. But maybe having something subtracted off it is going to help. Uh, 1 over 2k minus k over 2k plus 1 squared. I assume we probably want a common denominator. What do we get? We need a k plus 1 squared minus k squared over 2k k plus 1 squared. K plus 1 squared. Okay, well, we finally have something that converges. It has, basically degree minus 2. It, degree on top is 1, degree on bottom is 3. There should be something we can do data cancellation here to clean it up. I think, hope, pray. Mm-hmm. Do we split it up into like a k and a k plus 1? I can see the 1 over k squared series, but I don't see where exactly it is. Yeah, it's a nice song. I get stuck in my head sometimes. Am I missing some rearrangement of this? 2k plus 1. Wolfram Alpha saved me. No? I don't see what the hell you do with this thing. Did I make another mistake? I would believe it. The last time I had a minus was in this step. But then I had a k squared minus a k squared. Hmm. Did I do the integration right? I'm gonna be that guy who has to look up what the integral of 1 over x squared is. Or x cubed. The integration is fine? I assume what we want to get is a sum 1 over 2k squared, but I don't think I have that anywhere. I like barely don't have it. And we're going wrong. Like, I guess it's, well, I don't know. I see the issue is, but I am getting kind of tired and I want to wrap things up soon. So it's almost just like say the answer or something. Like I'm open to it. I don't see what I did wrong. I know I did something wrong here. Well, actually, wait. Are these just shifted? Well, okay, maybe there is something to do here. We can do some index fuckery here. I mean, the one on the right is going to be a little trickier, though. Should I... Is it better to do the index fuckery over here? A step before you do the common denominators. And do the index shifting there. From here? Well, I don't see how you do it there. One step sooner. From here. Or... It's where you did it. Don't know that it's best. Really? Huh. Maybe there is a more obvious form to write this thing in. I don't like any of what I did over there. Yeah, like we could I see now that there's that like offset there. Like that. But I don't see how index shifting helps. I do see that there's be the cancellations there, but they aren't even real cancellations because of that coefficient in front. That's what messes this whole thing up for me, I guess. Unless we split them into two different sums, then that's the idea. That's probably it. It's gonna mess up this K up there, though. Or not K, I guess. Okay, let's just ignore my complaints and keep going. If we turn everything back by 1 in the first series, we would have k plus 1 over 2 times 1 over k plus 1 squared minus k equals 1 to infinity k over 2 times 1 over k plus 1 squared, and then we can take the first term out of the first series, I guess, for k equals 0. So that's 1/2 times 1. And then do we involve these with each other again? What happens there? Oh, okay, this might be cleaning up now. Because if they already have a common denominator, so we have k minus k, and that's perfect. So we're gonna have 1 over 2 k plus 1 squared. Oh my god. So what exactly is the sum of one over, I guess it starts from n equals 1, right? Yeah, from n equals 1. And I'm out of room on the right. I need to turn this back. Well, so I want to start, I guess, from k equals 2. Put a 1/2 out front. 1 over k squared equal to 1/2 plus 1/2. Now we need to, we can say this is pi squared over 6, but we have to subtract out the first two terms, which are 1.5, 1 1/4. Pi squared over 12 minus 1/2 minus 1/8. That's not good. Wait, why did I do the second term? That shouldn't be there. Oh my god, pi squared over 12. God. That is a really neat question now that I see it. But there's also, like, so many traps of simplifying too soon. That is a neat problem that I see it though, Anders. Thank you. God, you gotta really do this carefully. Almost makes the problem worth it. Yeah, almost is the key word. Oh gosh. I think we gotta call it there. My arm is getting sore from writing in paint so much. I actually should get a tablet or something if I'm gonna not use the whiteboard. All right, I'm putting a YouTube stream up here, so if you're on YouTube, thank you.